Okay, now let us do this problem. This is again a problem related to relative masses, relative velocity. So let us see what this problem says. So this problem says two particles A and B, position vector A and RA and RB at time t. So we have two particles. So basically mass is not important. So particle A and particle B, their position vectors are RA and RB at time t. So this position vector is given at time t, where RA is given by, so RA is basically given by 1 plus t square I plus j, and RB is given by 3I minus t square j. So RB is given. Both particles starts moving when at t equals to 0. So both starts moving. So t is equals to 0. Motion starts. So motion starts at t equals to 0. So when to find the subsequent time when they close to each other, when they are close to each other, so we have to find time. What is the time when they are closest to each other? I think where they closest, when they are closest, when they are closest. So we have to find the time when they are closest to each other. So let us see. First find what are the position vector of A and what is the position vector of B at any time t. Initial vector is this. Do we have the velocity vector? No, we have to find the velocity vector. So velocity is nothing but, so velocity of A is nothing but differentiation of radius vector of A. So this is 1 plus t square I plus j. So t square differentiation is 2ti. J is a constant, so this is 0. So position vector of A at any time t, I can write initial position vector RA at time 0 plus Vt. So distance traveled is v into t. So velocity vector of A into time t. So RA0 is given. So this is at t equals to 0. At any time t, we know the position vector. So this means basically there is no need to find this velocity, because simply if I know the radius vector at time t, I can find the distance between two as simply. So there is no need to find out the velocity. So distance between these two particles can be directly calculated. So distance is nothing but, or you can say displacement, RB minus RA. So distance between B and A. So RB is 3t minus 3I minus 3I cap. So this is I cap minus t square j. This is RB minus RA. So 1 plus t square I plus j cap. So let us see, this is, so 3I minus t square j minus 1 plus t square I plus j. So now if I take the item one sided, so 3 minus 1 minus t square I minus t square, and this is minus 1, so into j. So let us say if I take minus common, so this is plus j. You're getting or not? So this is minus common, so minus minus plus. So this is 2 minus t square I minus t square plus 1 into j. Now we have to minimize this distance. So basically we have differentiation. So this is dr. So position of B with respect to A. If I have to minimize this distance, or basically I have to minimize the distance, so I have to take the mod also, because this is a displacement. So I have to take mod also. So what is the mod? So distance is, so root over 2 minus t square plus t square plus 1 whole square. I have to differentiate this with respect to time. So this term and then I have to differentiate, and then I have to put this is equals to 0. So either I differentiate this root, or even if I differentiate this whole square, both will give the same answer. So let us say differentiate this term, 2 minus t square whole square plus t square plus 1 whole square. So this is my y. I have to differentiate y with respect to time and then find time. So dy by dt is equals to 2 into 2 minus t square and then t square minus 2t. So differentiation of t square minus t square is 2t, plus 2 into t square plus 1, and then differentiation of t square is 2t. So I can put these values. So 4, so 2t if I take common, 4t I can take common, 4t if I take common, so minus goes here, so t square minus 2, so 2 plus minus minus plus, and then minus 2 into 2, this 2 is already common, so minus I have to simply multiply by minus, so minus t square plus 2. Now 4t is common, so I have to plus 1, and then I have to write this will be 4t and t square plus t square 2t square minus 1, this is equals to 0. So either we will have t is equals to 0 or t is equals to plus minus 1 by root 2. Minus is not a valid solution, so I have only one solution, that is ty 1 by root 2. So I can find minimum distance by putting this value t is equals to 1 by root 2, and the minimum distance is, you can find the time, we have to find only the time, so the time is 1 by root 2. So if we plot, so let us say if I am interested in plotting this function, how this will look. So distance, that's the minimum distance. If you see this curve, the distance curve, so distance square curve, so if I plot on the y-axis distance square, and here I plot the time, what kind of diagram I should be get? So can you expect? So this is something kind of parabolic, t square at t equals to 0, distance is 4, distance square is 4 plus 1 5. So at t equals to 0 we have a distance of 5 unit, distance square is 5 unit. So this is distance square at t equals to 0, we have 5 unit, 0 0, so we have 4 plus 1, so 5 unit. Now if you increase the time, so distance will decrease. If you t equals to 1, you see clearly, you can see 1 by less than 1 by root 2. So let us take 0.1. So if you take 0.1, you will find 1.9 whole square plus 1.1 whole square. So you can find this distance goes decreasing, and at a time 1 by root 2 this distance is minimum, and after that this distance starts increasing, because if you take t equals to 5 a square and then for square, so of course this distance will increase. So this is the point where this distance is minimum, that is 1 by root 2 second. So at this point, if you see, this graph is basically symmetrical about t axis, because you have t equals to minus t, so symmetrical about t axis, but negative time does not have any meaning. If you draw a dotted line, this graph will look something like this, symmetrical about t axis, but negative time does not have any meaning. Okay.